ChatGPT feels almost magical. You type a question, and a few seconds later, it responds with an answer that sounds surprisingly human. It can write code, plan your vacation, explain quantum physics, or help you prepare for a job interview. But behind that simple chat box lies one of the most fascinating engineering systems ever built. Thousands of GPUs, billions of parameters, millions of users, all working together just to generate a response. And here's the strange part. Despite everything you've heard about artificial intelligence, ChatGPT doesn't actually know anything. It doesn't think. It doesn't reason the way humans do. Yet somehow it produces answers that often feel intelligent. So what exactly happens after you press enter? To find out, let's follow a single prompt on its journey through ChatGPT. Imagine you ask, plan a 5-day trip to Japan. Seems simple enough, but the moment you hit enter, an extraordinary chain of events begins. The first thing to understand is that ChatGPT never sees your prompt the way you do. When you read, plan a 5-day trip to Japan, you see words, you see meaning. You might already be imagining sushi, Tokyo, Mount Fuji, and an overpacked itinerary. But computers? They don't see any of that. To a computer, language is just text. And before ChatGPT can do anything useful with your prompt, it has to translate that text into something machines can understand. Think of it like arriving in a foreign country. You know what you want to say. But before anyone can help you, your message has to be translated into the local language. That's exactly what happens here. The moment you press enter, your prompt leaves your device and travels to OpenAI's servers. And there, the first major transformation begins. Your sentence is broken down into smaller pieces, tiny chunks that the model can work with. These pieces are called tokens, and surprisingly, they're the foundation of everything ChatGPT does. Before ChatGPT can answer your question about Japan, it first needs to completely rethink what your sentence actually looks like. Let's see how that works. Remember our prompt, plan a 5-day trip to Japan. To us, that's a sentence, but to ChatGPT, it's not. In fact, ChatGPT doesn't really see words the way humans do. Instead, it breaks your sentence down into smaller pieces called tokens. Think of tokens as the building blocks of language. For example, a simple sentence might become plan a 5-day trip to Japan. Each of those pieces is then converted into numbers because deep down, computers only understand numbers, not words, not grammar, not meaning, just numbers. And suddenly, our nice human sentence starts looking more like a spreadsheet than a travel plan. But here's where things get interesting. Converting words into numbers isn't enough. Imagine I hand you a list of words: Japan, trip, plan, day, 5. You can read them, but you don't know how they're connected. You don't know which words matter most, and you definitely don't know what the sentence actually means. ChatGPT has the exact same problem. It now has a collection of tokens, but it still needs a way to understand how those tokens relate to each other. And that's where one of the biggest breakthroughs in modern AI enters the picture, a mechanism called attention. To understand attention, let's look at a simple sentence. The database crashed because it was overloaded. Quick question, what does the word "it" refer to? The database or something else? Humans answer that almost instantly. We barely even think about it. But for a machine, this is surprisingly difficult. The word "it" has no meaning by itself. To understand it, the machine has to look at the rest of the sentence and figure out which words are actually important. This is exactly what the attention mechanism does. You can think of it like a spotlight. Every time ChatGPT processes a token, it shines that spotlight across the entire sentence. Some words receive very little attention, while others become extremely important. In our example, the model learns that the word "it" should pay close attention to the word database. That's how it understands the relationship. And it doesn't just do this once. It does it over and over again, across every token, across every sentence, across entire conversations. This single idea became so powerful that it completely changed the field of artificial intelligence. In 2017, researchers introduced a revolutionary new architecture called the transformer. And at the heart of that transformer was attention. Today, that exact same idea powers ChatGPT. And while the mathematics behind it is incredibly complex, the core concept is surprisingly simple. Pay attention to the parts of the conversation that matter most. Now, after turning our prompt into tokens and figuring out how those tokens relate to one another, ChatGPT finally has enough information to do the thing it's famous for: generate an answer, or at least attempt to, because the next secret is the one that surprises most people. ChatGPT doesn't think, it predicts. Now comes the most surprising part of the entire story. Let's go back to our Japan trip prompt. By this point, ChatGPT has already broken the sentence into tokens. It has analyzed how those tokens relate to each other. It understands the context. And now, it's finally ready to generate a response. So, what happens next? Most people imagine ChatGPT searching through a giant database of answers, almost like a super-powered version of Google. But that's not what's happening at all. In fact, ChatGPT isn't searching for the answer. It's predicting it. Let's look at a simple example. Imagine I show you this phrase, peanut butter and... You can probably guess the next word. Most people would instantly say jelly. Not because they spend time reasoning about it, and not because they search the internet, simply because it's the most likely continuation. Your brain has seen that exact pattern thousands of times before. ChatGPT works in a surprisingly similar way. When it starts generating a response, it looks at all the tokens that came before and asks a single question. What is the most likely next token? That's it. Not, what is the correct answer? Not, what does the user really mean? Just, what token is most likely to come next? For our Japan trip example, the model predicts the words one by one. Japan is a beautiful country. One token at a time, over and over again. And that is how an entire paragraph is created. The answer you're reading wasn't generated all at once. It was built token by token, like laying down one brick at a time until a house appears. Now, here's where things get fascinating. If all ChatGPT does is predict the next token, why does it feel so intelligent? Why can it write code, explain complex science, draft emails, or help you plan a vacation? The answer is that prediction turns out to be an incredibly powerful skill. After training on enormous amounts of text, the model becomes exceptionally good at predicting how human language behaves. And when a system becomes good enough at predicting language, it starts looking surprisingly intelligent. But prediction comes with a hidden weakness. Because if your entire job is simply to generate the most likely next token, what happens when that prediction is wrong? That's where things start getting weird. Because sometimes ChatGPT can sound incredibly confident while being completely wrong. And once you understand exactly why that happens, a lot of its strangest behaviors suddenly start making perfect sense. Now that we know ChatGPT is a prediction engine, its biggest weakness suddenly makes perfect sense. Let's do a quick thought experiment. Imagine I ask you to complete this sentence. The capital of France is... Most people would immediately say, Paris, easy, because you've seen that fact countless times before. Now, imagine I ask you something much harder, something obscure, something you're not completely sure about. What happens? You might start guessing, you might fill in the gaps, and you might even sound incredibly confident while being completely wrong. That is surprisingly close to what ChatGPT does. Remember, ChatGPT isn't checking facts in a database. It isn't stopping to think, and it isn't raising its hand to say, sorry, I don't know. Instead, its underlying job is always the same. Keep generating the most likely next token. Most of the time, that's exactly what makes it so useful. But occasionally, the model encounters a topic where its prediction isn't backed by strong information. And when that happens, it can generate answers that sound completely believable but are partially wrong, or sometimes entirely made up. In the tech world, this phenomenon is known as hallucination. Not because the AI is lying and not because it's trying to deceive you, but simply because it's doing exactly what it was designed to do: predict the next likely token, even when certainty is low. That's why ChatGPT can produce an answer that sounds polished, confident, and incredibly convincing, while still being completely incorrect. But here's something even more interesting. Despite being fundamentally stateless at its core, ChatGPT somehow remembers the exact conversation you're having with it. You can ask a follow-up question, reference something from earlier, or continue a deep discussion for dozens of messages. So, if ChatGPT is really just predicting tokens one by one, how does it seem to remember anything at all? At first glance, ChatGPT seems to have a pretty incredible memory. You can ask a complex question, follow up 5 minutes later, reference a tiny detail from earlier, and somehow it still knows exactly what you're talking about. It feels almost like you're having a conversation with a real person. But here is the surprising truth. ChatGPT doesn't actually remember your conversation the way humans do. Let's imagine you're chatting with a friend. As the conversation continues, your friend naturally retains what was said a few minutes ago. Humans have working memory, but ChatGPT doesn't. In fact, at its absolute core, the underlying model is completely stateless. Every single time you send a new message, the model starts entirely fresh. So how does it seem to remember anything at all? The answer is surprisingly simple. Every time you hit send, the application takes your entire conversation history, your past messages, ChatGPT's previous replies, and your newest prompt and packages them all together into one single massive input. Then, it sends that entire history back to the model all over again. From the model's perspective, it's essentially rereading the entire conversation from the beginning before answering you. So, when you ask, plan a 5-day trip to Japan, and later follow up with, can you make it cheaper? ChatGPT isn't actively remembering your Japan trip. It is simply seeing those earlier messages sent back into its input queue and using them as fresh context. That's why engineers call it a context window rather than a memory, because the model isn't remembering the past, it's simply looking through a window into the past. But this clever approach comes with a massive physical limitation. Imagine trying to carry every single page of a long conversation in your hands. At first, it's easy. Then the conversation gets longer and longer and longer. Eventually, your hands are full and some pages have to be dropped. This is exactly why during very long chats, ChatGPT can suddenly forget details that were mentioned much earlier. Not because it chose to forget, but because those details simply no longer fit inside its context window. And once they are pushed outside that window, the model can no longer see them. But this raises another fascinating question. If ChatGPT doesn't truly remember things, then where did all of its world knowledge come from in the first place? How does it know about Japan, Python programming, history, science, or millions of other complex topics? To answer that, we need to go back long before your prompt was ever typed, back to how the model was trained. By now, we've uncovered some pretty surprising truths. ChatGPT doesn't search for answers, it predicts them. It doesn't truly remember your conversations, it simply uses a temporary context window. And yet, somehow, it knows an incredible amount about our world. It can explain Python programming, discuss ancient history, write compelling essays, solve complex math problems, and even help plan our dream trip to Japan. So, where did all of that knowledge actually come from? The answer begins long before you ever typed your first prompt. Imagine trying to become an expert on absolutely everything. Every book, every article, every website, every public piece of code ever written. Obviously, no human could ever do that. But that is essentially what happened during ChatGPT's training phase. Before it ever talked to a single user, the model spent months learning patterns from an astronomical amount of text, books, articles, websites, software documentation, research papers, and open source code. But here's the crucial part. Nobody sat down and manually taught ChatGPT rules like, this is how you write Python, or this is how you explain history. Instead, it learned the exact same way we've already seen throughout this video, by prediction. During its training, massive chunks of text were hidden from the model, and its job was simple. Predict what comes next. Again and again and again, billions of times over. Through this relentless process, the model became incredibly good at understanding how language behaves, how ideas connect, how explanations are structured, and how code is written. But even that wasn't enough, because a model trained only on raw internet text wouldn't necessarily be helpful. In fact, it would behave more like a chaotic autocomplete engine than a useful assistant. That's why the next step involved humans. Researchers showed the model examples of high-quality conversations, helpful answers, and clear explanations. Then, thousands of human reviewers helped rank its responses, teaching the model which answers humans actually prefer. Over time, those feedback loops transformed a raw prediction engine into something that feels deeply intuitive. And that's why ChatGPT can provide such incredibly useful answers. Not because it understands the world the way you and I do, but because it has spent an immense amount of time learning the underlying patterns of human knowledge. But there is one final massive piece of the puzzle. Even if ChatGPT can generate these impressive answers, how do you deliver them to millions of people around the world in just a few seconds? That is where the engineering challenge becomes truly massive. Let's zoom out for a moment. So far, we followed a single prompt. One person, one question, one response. But ChatGPT isn't answering a single prompt. It's answering millions of them every single day, all around the world. Right now, while you're watching this video, people are asking ChatGPT to write code, summarize dense documents, plan vacations, debug errors, prepare for interviews, and generate content, all at the exact same time. Each of those requests needs to be processed in just a few seconds. And behind the scenes, that requires an absolutely astronomical amount of computing power. When your prompt reaches OpenAI's infrastructure, it isn't handled by a single computer sitting in a server room somewhere. Instead, it travels through massive data centers filled with specialized hardware, engineered specifically for massive AI workloads. Rows upon rows of powerful GPUs, all working together in perfect sync, generating tokens, serving users, and handling an incredible volume of traffic every split second. What's truly remarkable is that despite all of this hidden complexity, the experience feels entirely effortless. You type a message, you press enter, and a response instantly appears. But behind that seemingly simple interaction lies one of the most ambitious engineering systems ever deployed on the modern internet. And that brings us right back to our original question. What actually happened after we pressed enter? Let's retrace that journey one last time. We started with a simple prompt. Plan a 5-day trip to Japan. The moment we pressed enter, the text began a journey through an incredibly complex system. First, the prompt was broken into tokens. Then, those tokens were analyzed using the attention mechanism inside a transformer model. The model looked at everything that came before and predicted the most likely next token. One token at a time, again and again, until an entire response emerged. Along the way, we discovered exactly why ChatGPT can write code, why it sometimes hallucinates, why it appears to remember long conversations, and how it learned deep patterns from enormous amounts of human knowledge. The surprising truth is that ChatGPT isn't thinking the way humans do. It isn't searching a giant database, and it isn't reasoning through problems step by step like a person. At its absolute core, it is an incredibly sophisticated prediction engine, one that has become so remarkably good at predicting language that it often feels genuinely intelligent. And perhaps that is the most fascinating part of all. Because from the outside, it looks like you're chatting with a machine that truly understands you. But behind the scenes, it's really a story about tokens, patterns, prediction, and some of the most impressive engineering ever built. So, the next time you send a message to ChatGPT, you'll know exactly what happens after you press enter.